In this video, we'll look at how to solve two more rational equations and step up their difficulty level a little bit. Before we solve them, let's just review our steps for solving rational equations. You list the restrictions, then clear the fractions, then solve the resulting equation, and then you write your solution set, making sure that you check for your restrictions. So let's do this process twice. First, we'll look at this rational equation. And in this rational equation, you see that your denominators of x minus 5 and x plus 5 are on the left side, and on the right side you have x squared minus 25. So before I do anything else, I'm going to factor this x squared minus 25 to make sure I know what our factors are that make that binomial. And that's x plus 5 and x minus 5. So it's actually the same two denominators that are on our left side. So let's list what our restrictions cannot be. What our restrictions are. The value of x could never be a positive 5, and it could never be a negative 5, because this would make one or more of my denominators equal 0, which would make some of my terms undefined. So now that we've listed our restrictions, let's clear our fractions. Now in this problem, we notice that we are going to have to multiply both sides by the least common denominator, and the least common denominator of all of these fractions is x plus 5 and x minus 5. That's what you need to multiply both sides by to clear all of the fractions. Now let's go ahead and distribute this, and then we'll proceed and do our steps afterwards. So when we distribute our x plus 5, x minus 5 to each term, our first term we see our x minus 5s cancel out, but that leaves us with 3 times x plus 5. Then we distribute our x plus 5, x minus 5 to our second term, and our x plus 5s cancel out, which leaves us with a plus 1 times x minus 5. Now we carry down our equal sign, and we distribute the x plus 5, x minus 5 to the right side. And in this term, both of our binomials cancel, so we are left with just a 2 in the numerator. Now let's distribute where necessary, and then we can solve the equation after that. We get 3x plus 15 plus x minus 5 equals 2. Then we have a linear equation. So let's combine our like terms. 4x plus 10 equals 2. Subtract 10 on both sides. So 4x equals negative 8. And we divide each side by 4, so we get x equals negative 2. So let's check our restrictions. Negative 2 was not restricted, so we have our solution, negative 2. Doing one more example together. In this expression, we see that we have a denominator of x minus 1 in both denominators. So what I'll do first is clear our fractions. Actually, before we do that, we need to state our restrictions. Almost forgot the first step. So our restriction for this example is that x can never equal 1. So if x equals 1, that would make my denominator equal 0. Now that I've stated my restrictions, I can clear the fraction. So I will multiply the left side of the equation and the right side of the equation by x minus 1. And you'll notice when I do that, on both sides of my equation, the x minus 1s cancel. So I'm left with x squared on the left side equals 1 on the right side. Now what I have here is a quadratic equation because I have an x squared. So to solve quadratic equations, we set it equal to 0. And we factor it. X plus 1, x minus 1 equals 0. And so we then know that our two possible solutions are negative 1 and positive 1. And before we write our solution set, let's check to see if either of these are restricted. And we see that 1 is a restriction, so that this cannot be one of our solutions. So our only solution for this is negative 1.